Good morning, everyone. We are from Group 5, and today we'll be presenting the challenges in managing IBS construction in Malaysia based on insights from the industrial talk by SRTS Muhammad Jamrus bin Muhammad Jamil. My name is Nur Shafizatul Naim, and I will be presenting on the construction sequence of precast concrete structure in Malaysia. This process is central to the implementation of industrialized building systems or IBS, which is increasingly promoted by the Malaysian government for sustainable and efficient construction. The process begins with the planning and design phase. Architects and engineers adopt IBS friendly design methods, ensuring that components are modular and suitable for off-site fabrication. These designs are submitted as shop drawings to the consultant and local authorities for approval. The CIDB's IBS score system is used to evaluate the extent of IBS usage, where higher scores can lead to government incentives or are required for public projects. At this stage, coordination with MEP designers is crucial to ensure that elements like conduit holes are included in the precast components. Next is the off-site fabrication phase. Precast and prestressed elements such as panels, beams, and slabs are manufactured in controlled factory environments. This ensures consistency quality, proper curing, and compliance with Malaysian standards like MS 1462 and MS EN 13369. Off-site production also allows parallel progress on site, such as foundation works, which helps reduce overall construction time. Once fabricated, the components are transported to the construction site. This typically happens overnight to avoid traffic and ensure timely arrival. Transportation logistics are carefully planned to prevent damage, especially for pre-stressed elements that are sensitive to vibration and impact. Coordination between the manufacturer and site team is essential to align delivery with installation schedules. Upon arrival, handling and unloading must be done with extreme care. Cranes are used to lift the elements, and the lifting chains must be balanced to avoid cracking. For example, a 5-ton element requires a 60 to 70-ton crane, which also demands sufficient space on site. Most defects occur during hoisting, so crane operators must be skilled and precise. If installation is delayed, proper storage is needed to protect the elements from soil contact and weather exposure. Installation begins with traditional foundation works. Then, precast elements are erected using cranes and connected through welding, bolting, or grouting. Alignment must also be precise. Any deviation from grid line or drawing can cause delays of up to a month due to reordering and reinstallation of the elements. MEP systems are integrated either during installation or through pre-installed modules. Coordination is key to ensure smooth integration and minimal rework. Finally, the structure undergoes inspection by consultants and authorities such as the IDB. They verify compliance with fire resistance, structural integrity, and insulation standards. Once approved, the project is handed over for occupancy. This marks the completion of the precast construction sequence.
Now that we have explored the construction sequence, let's look at the key challenge involved in maintaining the quality and integrity of precast prestressed elements. This challenge occurs across multiple stages, from transportation to installation, and require careful management to avoid costly delays and structural defects. The first major challenge is transportation logistics. Precast. Precast elements are often large and heavy, and their delivery must be carefully planned. Poor road conditions, such as potholes or uneven surface, can cause a micro cracks, especially in pre-stressed components. Vibration during transit also poses a risk. Coordination between the manufacturer and site team is essential to ensure timely delivery and minimize damage. Since logistics are often handled by third-party transporters, quality control during this phase can be difficult. Next is preparation and coordination. The manufacturer typically sets the casting and delivery schedule, but the contractor must ensure that installation is ready on site. This includes crane availability, site access, and machinery readiness. Poor communication between parties can lead into idle equipment and wasted time. Additionally, MEP integration must be planned early. Designers need to clarify conduit openings with manufacturers during the design phase to avoid rework later. The third challenge is on-site storage. If elements cannot be installed immediately, they must be stored properly to prevent deterioration. This means placing timber planks on the ground to avoid direct soil contact and protecting the components from rain and sunlight. Since deliveries often arrive early in the morning, the project manager must ensure that the site is ready and the machinery is on standby to avoid delays and damage. Next, we move to handling and unloading. Handling and unloading is one of the most critical phase. Crane must be appropriately rated for the weight of each element. For an example, a 5-ton beam requires a 60 to 7-ton crane. The lifting chains must be balanced and the crane movement must be smooth and controlled. Most defects occur during hoisting, especially if the element is tilted or lifted too quickly. Site constraints such as limited space or uneven terrain can make this process even more challenging. Finally, alignment and fit of structures is essential for successful installations. Precast element must match the grid lines and dimension specified in the drawing. Even small misalignments can lead to the delays of up to a month due to reordering and reinstallations. Tolerance must be strictly checked, and the jointing method, whether grouting, bolting, or welding, must be executed with a precision to ensure the structural integrity. In conclusion, while precast construction offers many benefits, maintaining quality throughout the process requires careful attention to logistic, coordination, handling, and installation accuracy. Addressing this challenge is key to ensuring the long-term performance and safety of IBS based on structure in Malaysia.
My name is Nurul Natasha Izzati and I'll be presenting on the key consideration in repair and strengthening of precast concrete elements. Based on insights shared by Sir T.S. Jamrus bin Muhammad Jamil in his industrial talk. So first, durability and moisture protection. Our tropical climate causes precast element to undergo frequent wet and dry cycles. This lead to microcracks which allow water to enter and corrode the internal reinforcement. So joints are especially vulnerable to moisture. To prevent damage, we should surface waterproofing, inspect regularly, and seal cracks early with epoxy or polyurethane materials. So number two, the joint integrity and sealing. Joints connect precast component but often fail due to thermal movement, aging, or poor workmanship. Common issues include leaking joints and corroded connectors. So the solution is to use flexible sealants, replace worn joint fillers, and check grout condition regularly to maintain strength and water tightness. So the last one, cracking and structural damage. So crack can form from mishandling or overloading. This range from hairline to structural cracks that threaten to safety. So we handle this by monitoring cracks, injecting epoxy into structural ones, and patching surface defect using polymer modified mortar. Applying a protective coating afterward also helps to prevent future damage. So, in summary, proper maintenance of precast element requires addressing moisture risk, joint performance, and also cracking issues. This step helps to extend service life and also keep structures safe in Malaysia challenging environment.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan Wisamuddin. Today, I will like to present about my point, which is two practical solution on site uh, for repairing the precast concrete or precast structure on site. First, we can use the polymer modified mortar, which is PMM. This is an easy and cost-efficient way to repair crack, spell the surface, and shallow defect. PMM, which is polymer modified mortar, stick well to existing concrete, keep the moisture out, and stop small problem from the turning into the big one. So this simple repair method can extend the service of life of precast element without the need for a major work. So for the second one is a good option is wrapping it with the carbon fiber reinforced polymer, uh, which is CFRP. This method can help make weak part become more stronger in both bending and shear. So CFRP, which is carbon fiber reinforcement polymer, is light, strong, and doesn't change the look of the structure much. By using this method, together with the regular inspection and maintenance, we can keep the precast structure in good condition for a long time with less cost and disruption.